Hi guys, I am back and we're looking at our online lesson, week 4, lesson 3. So lesson 4.3 from online. In that lesson, what they talked about two things. One, they talked about how to write the inverse of a function that is not a linear function. And then they also talked about how to tell when two functions are inverses of each other. So the first thing that they did was they review how to write the inverse of a function that's linear. So f of x equals to negative 4x plus 8. Well, first thing I would do is I'd take that f of x and I'll change it to y. Because remember, whenever you're writing the inverse function, the first thing you do is you take x and y and you swap their places. So y now becomes x equals to negative 4. That x now becomes a y plus 8. And then from there, you are going to solve for y, meaning get y by itself. Pam does backward. I'm going to subtract the 8 on both sides. So that's going to leave me with x minus 8 equals to negative 4y. And then I'm going to divide negative 4 onto everything. So that's going to leave me with y equals to, I got an invisible 1 on top right here in front of the x, so it'll be negative 1/4 x, and then you have a negative 8 divided by negative 4. That's going to give me a positive 2. So rewriting it with the correct notation, you can't just have a y out here because 1 started with f of x, and you can't just put an f of x because this is the inverse of that f of x. So f inverse, that little negative 1 in the power, that's the inverse notation. So f inverse of x equals to negative 1/4 x plus 2. And that would be my inverse function of my f of x, negative 4x plus 8. Okay, so that's a review from last lesson. And then it goes into, well, what happens when your equation is not a linear to begin with? So that's going to give me, that's example 4 on the lesson on your notes. So f of x equals to x cubed minus 2. We do the exact same thing. So I'm going to take the f of x, change it to y. And from there, I switch the x and the y. So I have now x equals to, instead of x, I have y. So y cubed minus 2. So now I'm going to get I'm going to get y by itself by undoing everything around it. So Pam does backward. I'm going to add 2 on both sides. That leaves me with x plus 2 equals to y to the 3rd power. Now this brings back the very, very first week of lesson. How do I get rid of that exponent? Well, I have an exponent of 3. To get rid of it, I'm going to need to use a root. And in this root, because I have an exponent of 3, I have to have the same index, so index of 3. Do it to both sides, cube root on both sides. That's going to leave me with y equals to cube root of x plus 2. Again, I can't just leave this as y because 1 is started with f of x. 2, this is an inverse. So this should be written as f inverse of x equals to cube root of x plus 2. And that is the inverse of my original function, x cubed minus 2. And then it gave you another example. I gave you some practice, and then it gave you another example. Hey, what if instead of starting with a exponent, I started with a root? I started with a radical. So same idea. Change your f of x to y, and then swap your x and y. So I got x equals cube root of y minus 7 plus 2. Okay, so now let's get y by itself. Adding 2, that means I'm subtracting 2 on both sides. That gives me x minus 2 equals to cube root of y minus 7. Now, to get rid of that to get rid of that cube root, I have an index of 3, meaning I need an exponent. What exponent do I need? Same as my index. I need an exponent of 3. So that means that I need to take an exponent of 3 right here. So that's going to leave me with x minus 2 cube equals to, that exponent cancels out my radical, y minus 7. And to get y by itself, I add 7 to both sides, leaving me with x minus 2 cube plus 7 equals to y. Again, I can't leave this as y because it's given as f of x, and it is an inverse of f of x. So my final answer, f inverse of x equals to x minus 2 cubed plus 7. That is the inverse of my original function f. Okay, so that's the first part of it. How do you write the inverse of a function that's not a linear function? The second thing, there's a lot of examples and stuff, right? And then they talked about, well, how do I know if two functions are given are inverses of each other? Meaning, for example, how do I know that this function is an inverse of this function and this function is an inverse of this function? Well, one thing that they talked about was when two functions are inverses of each other, this is going to happen. When you take the first function and then plug in the second function, so take whatever equation the second function is, plug that into your first function, that it's going to leave you with just x. It's going to cancel everything else out and leave you with just x. And it has to work the other way around. So it's not an and, it's not an or, but it's an and. If I give you g of x, and if I plug f of x in there, if I do that, that has to equal to x also. So you got to check two things, right? So let's double check. Let's take a look at that first example that they gave you. They say f of x is x cubed minus 7, and g of x is cube root of x plus 7. Well, how do I know that these two functions are inverses of each other? I'm going to check this. The first thing I'm going to check, if I take f of x, and instead of just x, I'm going to plug in my g of x. Well, what is my g of x? My g of x is this whole thing, cube root of x plus 7, right? So that's this thing right here, cube root of x plus 7. That means what they want me to do is they want me to take this cube root of x plus 7 and put it inside f of x. So f of cube root of x plus 7. Well, how do I do that? Here's my equation. F of x equals to x cubed minus 7. What do I plug in instead of x? I am going to plug in cube root of x plus 7 right there in just the x. So I'm going to put a parentheses around it. Cube root of x plus 7. That's just my x. I always put a parentheses around my x. And then you got a cube up here. And then don't forget, you have a minus 7 back there. So what happens when you have a cube and an index of 3? These two are the same. It cancels it out. That leaves me with x plus 7 minus 7. Plus 7 minus 7 cancels out, equals to x. Everything goes away, leaving me with just x. Right, so that's one part of it, and then I have to check the second part. Sorry guys. Here's my second part. You go, well, if f works, what if I put g of f of x? Right, f of x. What's that? That is x cubed minus 7. So what I'm really looking at is this. I'm looking at g of, instead of an x in there, I'm going to put in x cubed minus 7 in there. So here's my g. G is cube root of x plus 7. So cube root of, but instead of x, I'm going to put in x cubed minus 7 in here. And don't forget I have a plus 7 at the end, inside, right? So I get this left. Minus 7 plus 7 on the inside goes away, leaving me with cube root of x cubed. Now if you look, x cubed and cube root both have the same index and exponent, so those things goes away, leaving me with just the x. So this one has just the x, this one has just the x, because both way works. I would say yes is an inverse of each other. Right? So I would say that f of x and g of f of x is the inverse of g of x. Same thing, g of x is the inverse of f of x. So what happens if you don't, right? So let's take a look at this example right here. Okay, let's take a look. I can do the same thing. Is f of g of x, I need to figure out if that's equals to x. Right, so g of x is this thing, cube root of x plus 4. I'm going to take that and plug it into the x, just the x of the f of x. So I get this happening. F of x is x cubed. So I'm going to put a parentheses around the x because that's what I'm plugging in. I'm plugging in cube root of x plus 4 right there. That's x. Don't forget that I have a cube right there, plus 4. Okay, so this becomes that. Well, let's see what's happening. Index of 3, exponent of 3, goes away, leaving me with x plus 4, and then plus 4. What's x plus 4 plus 4? That's x plus 8. X plus 8. Is that equals to just x? Nope, that is not equals to just x, so I can say not inverses. They are not inverses of each other. Y'all, this is a lot of work, but there's another way to do it. If f of x is an inverse of g of x, and g of x is an inverse of f of x, I can take one of these equations and find the inverse, and it should match the other equation. So, for example, this is another way, right? If I say, are these two inverses of each other? Well, I can take f of x and find the inverse of f of x. So I can say f of x equals to x cubed plus 4. Let's find the inverse. You know how to do this. Now you change this to y, swap the x and y. X equals to y cubed plus 4. And then get y by itself. Minus 4 on both sides. Leaving me with x minus 4 equals to y cubed. Take the cube root on both sides. If I take the cube root on both sides, that leaves me with y equals to cube root of x minus 4. Let's look. Is y equals to cube? This is supposed to be my inverse, so that's like y inverse, right? F of x, f inverse of x. But if I'm looking at this, does this match this equation? No, because this inverse is x cube root of x minus 4. The equation they want me to match was cube root of x plus 4. So I would say not inverse because f inverse of x is not equal to that other equation, g of x. you could have done it this way too. So instead of doing all these crazy substitution, you could have done, find the inverse of 1. Does that inverse matches the other equation? So just a different way of looking at it. I hope this helped. If not, just keep asking questions. Just keep talking to me online.